Let's look at the green pocketbook in action. Let's say I'm researching if benzoic acid is a toxic chemical since it is being used in my experiment. So I come to the search bar and I type in benzoic acid and search. So one of the first things you see is the structure. Instead of typing out benzoic acid, a cool function is a search by structure function. If I know the structure, I can draw it out and get the same information. Another really cool option is you can draw new molecules that are desired and have on-the-spot toxicity estimations for them. This can be especially useful in industry practices. The first tab shows me everything regarding the physical properties, ranging from the boiling point to the flash point. Any values that are missing on this tab are estimated using QSAR models. Soon we will be able to show you which values are experimental and which values are estimated. I can click over the Related Information tab. By clicking this, it will take me to the citations and patents which provided this information. GHS classifications, which typically include fire or health hazards, can also be found under this tab. If I go hover over this yellow triangle, I can see the regulatory list which this chemical is found on. If I actually click it, I'll get a printable list. The second list is a toxicology tab. The toxicology tab has the important but difficult to understand information regarding the relative toxicity of the chemical. There are 27 properties found on this list, ranging from the bioaccumulation factor to the ozone rate constant. I can hover over each of these measurements, and as you can see here, it gives you an explanation of the model used to deduce this information. Very soon, you will also be able to see the source of the information and whether the data is experimental or estimated. So there are a large amount of measurements with different values, but no set standard to pool all this information together. So that brings us to the green scores. The green scores takes all this information and compiles it in an easy to understand manner. The scores are based on the 44 endpoints recommended by the United Nations, EPA, and REACH guidelines. It is broken down into 3 top-level scores: ecological, health, and safety. These can be expanded into individual paths, such as water, air, and soil, and within these, I can go to subcategories, which also tell me exactly what was measured. For example, the water exposure was based on the concentration and exposure limit of the chemical. So these scores take the property values, apply a proprietary algorithm to measure a score, and then normalizes that score on a scale from 0, meaning least toxic, to 4, or most toxic. So now let me just give you an example of how scientists can solve their headaches when it comes to choosing what reagents or solvents to utilize using the Advanced Compare feature. By providing the limitations in terms of physical properties, the perfect chemical that suits your needs can be determined. So let's compare some similar chemicals as benzoic acid. Let's say I want the same functional group, which is a carboxylic acid, but let's say I want a different boiling point because the boiling point of benzoic acid is 276 degrees Celsius. So I come to this and I choose boiling point and I set my limits from between 110 degrees Celsius and 120 and I submit. So now it goes and sifts through the database for the chemicals that search my proprietary needs. And let's say I choose acetic acid. The Advanced Compare tools puts these chemicals side by side and I can see the green scores against each other. So let's try one more. Let's search the same functional group, but one that has a different vapor pressure. So I choose my functional group. And so these are the various filters that you can use. I just happen to use boiling point and vapor pressure. So it rifles through the database again, and alright, let's choose formic acid. As you can see, a carboxylic acid. So as we can see, the green scores are overlaid with different colors with a legend at the bottom, and we can have a direct comparison of these chemicals. As you can see here, all 3 chemicals rank pretty high on chronic health score, meaning that prolonged exposure to these chemicals can have harmful side effects. However, if I look at the red and the yellow, which is benzoic and acetic acid, I can see there are high acute health scores, meaning that short-term exposure is extremely dangerous. However, the formic acid has almost close to nothing for acute toxicity. So you can just conclude that selecting formic acid is the least toxic choice and should be used as replacement for benzoic acid in the experiment. So this is just a single example of advanced comparison tools. I showed you there are a lot of different filters which can be used. Thank you for listening, and I hope to see you using Green Pocketbook soon.